Alright, so today we are going to be using infrared and mass spectrometry to identify an unknown. There are 5 IR zones total. The first one starts from around 4,000 to 3,200 on the chart here. So from this area. This includes alcohols and amines and things like that. Many alcohols will have a very parabola-like shape, and amines will look either like double fangs or long points. Moving on to zone 2 is from around 3,000 to about 2,700, and this area is mainly for single bonds, sp3 carbon-hydrogen bonds. The third zone is the triple bond area, and that goes from around 2,200 to 2,000. Zone 4 is the carbonyl zone from around 1850 to 1550. It's right in here. And then zone 5 is a double bond area from around 1550 to 1350. So this area right here. Anything beyond that over here is considered the fingerprint zone, and it is not analyzed. For mass spectrometry, we have 5 different steps that we use. The first one being that we find our M+, which is usually the peak farthest to the right on our graph. We will write that down and we will use that later. Secondly, we will go to our base peak, which is the largest peak on our graph. Thirdly, we will find the formula. Now there are some elements that we can find based off mass spectrometry alone. Many times it is necessary to use IR spectrometry to identify as well. Once we have our formula, we can count our degree of unsaturation, or our DOU. The formula for this is taking 2 times the number of carbons that we have, plus 2, plus the number of nitrogens, minus the number of halogens, and minus the number of hydrogens, all over 2, divided by 2. This will tell us a general idea of what our structure will be like, and from then we can list off possible structures. So now we can put them both together, IR and mass spectrometry, and use them to find an unknown. The 2 graphs here are based off the unknown that we are trying to find out today, and we will start off by going and looking at IR spec first. So we're going to start on the left and go to the right. We will be looking at our zone 1 right here, and we can see we have a massive parabola looking shape, which is indicative of an alcohol. So that is something to keep in mind. We may have an alcohol of some sort. Next we'll go to zone 2 in this area, and we can note that we do have some single bonds to carbon and hydrogen, some sp3 bonds. Not much going on in these areas. You will notice some very small peaks, but nothing worth noting. Finally, we will go over to the 5th zone, which is carbon-to-carbon double bonds. Now, this more looks like a jumbled mess than anything. It's possible, but not probable, that we have those in our molecule. So remember, this part is the fingerprint zone, and we do not analyze this. So now we're going to go over to our mass spectrometry chart right here. We're going to start off by finding our M+ peak, and it is looking like we have a very small peak right here at about 47. That is just a very slight fragment, and we do not include that. We'll go one to the left to where at 46, where we have a peak that we can actually use. So M plus will be 46. Then we'll go find our base peak, and that is definitely looking like it will be 31 here. Keep that down. That's our largest peak, coming all the way up to 100 almost in our relative intensity. The next thing we will do is try and understand our formula. So, going back to IR, we have an alcohol. We know alcohols are OH, an OH bond. So we have an oxygen and hydrogens, absolutely. We also have carbon to hydrogen single bonds, sp3 bonds, as we noted here. So with knowing that, we know we have carbons, hydrogens, and an oxygen, possibly more. So with that, we will take our M plus, which is 46, and we're going to subtract the mass of an oxygen that we know we have from the periodic table, which is roughly 16. So if we take 46 minus 16, it gives us 30. So from there we can gather that we have at least one oxygen present in our molecule. From there we're going to move on to the carbons. Carbon, the mass is about 12. So we're going to subtract as many carbons as we can from that previous 30, getting a total of 2 carbons, which adds up to 24. So 30 minus 24 is 6, and then we try and find out how many hydrogens can we fit in there with a mass of 1, which we can fit 6. It totals out to 0. So it's looking like we have a formula of C2H6O. When we do the degree of unsaturation for that, and we plug it into our formula, as mentioned earlier, it comes out that we get a DOU of 0, which tells us we have an alkane with 0 pi bonds. So no double bonds and no triple bonds. From there on, we can go and identify the possible structures. As a recap, from our IR spectrometry, we could find that we had an alcohol and an sp3 carbon to hydrogen bond. From mass spectrometry, we were able to confirm our formula, and knowing how many carbons, hydrogens, and oxygens are in the molecule, as well as a general idea for our structure. So knowing that we have an alkane, no sp2 or sp bonds, or pi bonds, we were able to come to the conclusion that we have an ethyl alcohol molecule. A carbon here, 1 carbon, 2 carbon, bonded to an O and an H, so that gets rid of our 2 carbons. Our O, 1H, we have 2 hydrogens coming off of here, and 3 hydrogens coming off of here, of this carbon. And that fits exactly what we have found in our spectrometry. So that is how we do it. That is how we get to the final structure and product, just by looking at infrared spectrometry and mass spectrometry graphs. Thank you.